All right, let's take a look at the periodic table and kind of make some more sense of the periodic table. First off, don't forget, you see the 1, the 2, the 3, 4, okay, that's equal to what we call the atomic number. We're going to be talking about that in the next part. And that's equal to the number of what? Number of protons. You're like, okay. So, what are ways that you're going to need to know, or what are ways of chunking up the periodic table you're going to need to know? First off, there's this important, what I call the jag. It's a diagonal jag that separates the metals from the nonmetals. Which, right off the bat then, do we have more of? Do we have more metals, or do we have more nonmetals? We definitely have more metals. These down here, what color do they go with? Do you think they're metals or nonmetals? Those down there are definitely metals. Right? So that's an important jag. Okay, now, yeah, an important way of taking the periodic table and chunking it up. So notice that we kind of have some, these are green colored, and they actually, the boron isn't green colored, but there are what, 7 elements identified there that are along the jag. They have kind of properties of both being metals and both being nonmetals. So they're actually what we call metalloids. Remember, the jag separates what? Metals from nonmetals. Nonmetals. Okay, so the metalloids are kind of along the jag, metalloids. And we've been talking about these kind of the columns or the groups. They are where the chemical similarities are. They're like days of the week. And each group has a name. That's 1B, 2B. Can you see that's group 3A, group 4A, group 5A, group 6A, group 7A, and group 8A. Now, some groups have special names, like the I mentioned the halogens a minute ago. You're going to need to know those. But I need you to know the group names. Oops, I wonder if this is not recording. Hope it is. Okay, so for instance, over there where it says hydrogen, can you see above the hydrogen it says group 1A? Above beryllium it says group 2A. Okay, that sort of thing. Let's see if it'll let me go on the next slide. Okay. So another thing you need to know is, are the main group elements versus the other elements. So main group elements look like this. Okay. Now notice, if I were to ask you what they all have in common, can you see that they are all designated A's? Okay. These are the 1A through the 8A main group elements. Sometimes I call them main group elements, and sometimes I call them group A elements. Does that make sense? Okay. And what else do we have? The group B elements are called actually the transition elements. So sometimes can you see where these are all group B's? Okay. Sometimes I call them group B, otherwise known as transition elements. So since they're all metals, sometimes they are actually called transition metals too. I just love elements. They are so fun. Okay. All right. So it's all where the group is very important. Now let's talk about the rows. The rows are called periods. That's period 1, period 2, period 3, period 4, then we go through the transition metals, period 5, period 6, and period 7, okay? Now notice that, I'm going to talk about it here in a minute, but this idea that we've got some highlighted down here, well, I'll just go ahead and talk about it right here right quick. You see this thorium-90? Actually, it inserts right here between actinium and rutherfordium, I think. Okay, right here. This goes right here. So period 7, okay, starts with francium and goes all the way through, it goes jeep, jeep, jeep. Okay, that's period 7. All right. So speaking of, now we have the two kind of rows down here at the bottom. I said thorium kind of inserts between actinium and rutherfordium, and cerium inserts here between lanthanum and I think hafnium. I'm not sure. Okay, but you see where it goes 57, 58, and then 58 all the way to 71, and then 71 picks up again here at 72. You see how that works? So that's actually the same period. That's actually period 6. Okay, and they're called the lanthanide series down here because they go in after lanthanum. And then down underneath them on the bottom, we have the actinide series that inserts between actinium and rutherfordium. I think that's the name of that one. So similarly, notice that we have atomic number or 89 protons here. We have 90 protons here. It counts up, increasing the number of protons. It goes to 103, and then here it goes back to 104 and continues on. By the way, and I'll be talking more about this, the periodic table actually has been filled out with these guys as elements. They had completely filled period number 7 now. That is so cool. I've updated my periodic tables for your test and everything. So there we go. What else do we have? Okay, so those two down there are actually called the inner transition metals. So collectively, the lanthanide series and the actinide series are the inner transition metals. I'll buy that. Then we go on to, I said that there are some groups that, like group A, 1A elements, not hydrogen, but getting with lithium, sodium, potassium, rubidium, cesium, and francium, they have a special name called the alkali metals. And then you need to know that. Here's a picture of them. Aren't they pretty? And they have similar reactivity. You're kind of seeing the reactivity with water there of sodium. It's kind of an explosive sort of thing. Another group I want you to know are the 2A. Those are the alkaline earth metals. So you need to know that name. And here's kind of what they look like. Kind of pretty. Actually, you guys are going to be doing this right here with the magnesium. You're going to be burning it. Kind of shown here. Here's calcium. You guys did this in lab where you took a piece of calcium metal and you put it in water and it bubbled, created hydrogen gas. So those are two groups. A third group then is, we have two more groups. A third group over here is the 7A, and I've said before that they are the halogens. And so here's kind of what the halogens look like. And then last but not least, I need you to know group 8A. And group 8A actually have 3 names, good, bad, or otherwise. They're called, I probably call them the rare gases the most, because they're, I guess, relatively rare in finding them on Earth. They're also called the inert gases because they don't like to react with anything. And then last but not least, kind of related to their rarity, I think they're called the noble gases. So group 8A gases actually have 3 names. So this is just kind of, and here's the, here are the noble gases. Okay, very helpful. I'm going to go back to this. So did you guys know that actually helium's got a neat history with, I love elements. Helium during, I want to say, was it World War I and II maybe, that helium was actually put on a national, the military wanted to keep it under lock and key because we only have a certain amount of helium and it was important for the war effort. These days, though, helium actually is becoming, there's a scare for helium, and you know, once you use helium, actually we are losing helium from the Earth. I just think that is so cool, and you can't recreate it without nuclear fusion, as like the sun is doing in its core. Anyway, okay, so this is actually just a photo to kind of show you an assortment of elements, and I just love elements.